Okay, perfect. All right. Hey everyone, my name's Cody.
I'm Isaac.
And we're also joined on the project by Igor, who unfortunately couldn't make it here today, but you can see his picture there. And we're working on the Liquid Energy Dollar project, which is a decentralized energy stable currency. So going into a little bit about the motivation. So despite Ethereum's programmability and expressiveness, all that we've done today with the best of the stablecoins that we have, the most used ones, are really just copy-pasted versions of fiat currency. And that brings a lot of benefits, but as we've seen over the past couple of weeks, there's also a lot of downsides to that. So we wanted to think from the ground up, if we were to build something from scratch, what would a truly digital native currency that's a stablecoin look like on Ethereum? And so what's wrong with fiat currency? Well, this is a graph showing the consumer price index over time. And as you can see, something happened in 1971. And we're basically just, by holding on to fiat currency, we're basically just eroding our value. Our buying power is lost over time. So this is a graph. The blue line is the CPI. The red line is the value of energy. And then the green line at the bottom that's flatlined is the US dollar. And so what you can see here, what we've proven is that energy is strongly correlated to the consumer price index, meaning that if you could create an energy stable currency, then you would be able to save in a value that holds its peg relative to what you care about, basically your buying power.
So one of the major roadblocks to constructing a currency that's based off of energy prices is getting some metric on chain that represents energy prices in a trustless and decentralized way. And so what we've found is that we can use data from the Bitcoin blockchain to act as a proxy for that. The way you can think about it is that Bitcoin mining is a competitive market. You have people that are expending energy in terms of hash rate to obtain rewards, basically the Bitcoin that they get for mining each block. And taking these two metrics together, you can get a reasonable proxy for global energy price. And so what we've done is we've constructed a model that takes those inputs from Bitcoin, accounts for some factors like energy efficiency of computation over time, and applies like an exponential smoothing factor. And we've managed to get a price index that closely correlates to the energy CPI over time. So what we've done specifically for the Spark program is we've constructed an oracle. We're able to get Bitcoin block header data onto the chain in a trustless way. We're also able to take exchange rate data using an oracle, and we're able to spit out a price that correlates to the energy CPI.
So really quickly, over the course of the Spark program this past month, what we've done, we made some major improvements to the LED model, which was the graph that you just saw 2 slides ago. We also did some research as to how to most effectively migrate Bitcoin block headers to Ethereum. And then, of course, as Isaac mentioned, we implemented this and have deployed it to Optimism. We set up automation, monitoring. We have a Dune dashboard, so you can see the price in real time. And then today we launched a website and made this all public. And this is the QR code for the website. Thank you.